Okay. Good. So, good morning, everybody. It's a pleasure today to have Professor Jussara Almeida here to give us a talk about uncovering the individual and social behavior patterns online, research on fake news, political campaigns, and hate speech. Jussara, she is a full professor at Universidade de Minas, Gerais in Brazil, and she leads the social computing laboratory at the Department of Computer Science. She holds a PhD from University of Wisconsin, Madison in the US, and she is a former affiliate member of the Brazilian Academy of Sciences. Her areas of expertise are workload and user behavior characterization, performance analysis, and modeling of large-scale distributed system and social computing. She has published more than 270 papers and has been senior member in the technical committee of the top-notch conferences in our field, like the World Conferences, ACMRFCs, KDD, Wisdom, and more. So it's really a pleasure and an honor to have Jussara here today and to listen from you.
Thanks a lot. Thanks a lot for the opportunity. It's first time here in Padua, and very, very nice opportunity. Thanks a lot. And thank you guys for coming to listen to me. So as Nicola said, I'm talking about modeling user behavior online. I'm going to try to talk about several works that we've been doing in this direction with particular focus. I changed the title slightly to emphasize this idea of collective behavior, which is more specific to social behavior, and I'm going to talk specifically about that. And I will add some other stuff along the way related to what I do. But before I talk about that, let me tell you where I am in Brazil. Usually people think of Brazil, think of Rio first, São Paulo, and they never think of where I am exactly, which is Belo Horizonte. Neither of those places. Belo Horizonte is in the countryside, is in state of Minas Gerais. We do not have beaches, but we do have hills, nice hills around. Our university is quite large for Brazilian standards. And our department, the computer science department, this is an old picture. It's going to be 50 years old in 2026. It's for Brazilian standards, traditional old computer science. We are around 65 faculty. And myself, as mentioned, I lead the social computing lab. And it's interesting so that you follow what I'm going to tell you and see how this fits in computer science to know a little bit of my trajectory as a researcher. So I always liked performance, understanding system performance, how a particular system, especially distributed systems, behave in the most basic sense of performance initially. So by the early years of my PhD, I was actually developing performance models for web systems, tweaking operating system kernels should make web system work better. So I was in that mindset in terms of system design. But then by the end of my PhD, I reached this realization that there was something missing in my research that was very system focused, which is looking at users, how users use the system, user behavior. Because the workload that is imposed on the system is derived from these behavior patterns. And if you don't understand the workload, you cannot understand the performance. So I was naturally driven into this new world where you focus on the user. But I'm very well set into system design. So I'm looking at how users behave, but I'm thinking, how can this impact the system? Because this generates this cycle, which hopefully virtuous, but often vicious, where users behave and generate workload into the system responds and may actually drive new behavior. So that's where I am. And currently I'm developing research into two major lines. One, which is the focus of this talk, is information dissemination in social media. And I want to understand what makes a piece of content become very popular, how the user behavior drives that. Another is human mobility. So here, even though mobility occurs in the real world, not system, Mobility drives many system designs like recommendation, allocation of resources in cellular networks. So lots of people in computer science want to understand and model human mobility. And then here I'm interested in trying to do two things. One is predict, everyone wants, and now we are working on federated learning in that context. But another, which is something more related to the user and less related to the technique, is predictability. How predictable a person is. Because if a person is very exploratory, changes a lot, visit new places every day, most probably any prediction that you make for her will be risky and possibly unreliable. So there are ways of estimating that measure of predictability, which is related to user behavior. And we're trying to develop metrics related to that. Today, I'm not talking about mobility. I'm talking about information dissemination, and I'll focus on this line. And here, obviously, you can think of different aspects of human behavior that affect how a piece of content is spread around. You can think of users individually, and then there are like personal interests that should be aligned with content properties. So there are lots of research that we do trying to characterize the properties of the content. And that's where my research meets Marco's research, because I use lots of techniques from information retrieval, NLP, to try to infer topics and infer properties of those contents and match that with these. But also, there are other aspects related to personal bias. So when you study something like fake news dissemination, something that I'm doing, you have to know that users have a personal bias in the way that the brain works that drives you to collaborate with the process. So this is where my research touches very slightly other areas like human sciences and psychology, to try to bring these notions, these biases into understanding the dissemination process. And one such effort is one thing that we're doing now, which is curiosity modeling. So think of recommendation. You want to recommend something that pleases the user, that is usable to it. So there are many huge literature on recommendation, exploring different signals. In the last years, people start bringing to this domain of recommendation the notion of curiosity. So the user is pleased with the content that triggers this curiosity. He wants to go and look into that. Then if you look into the psychology domain, there is a vast literature on modeling curiosity of a person. And what computer scientists start doing is trying to bring this notion that is very abstract to recommendations as a signal. So you add to the recommendation function something like relevance, diversity, but also signals that, oh, this probably will trigger the curiosity of this user. So you give a greater weight to this. How can they do that? So there is, for instance, something from psychology that is called the wounds curve. This is a very theoretical and abstract model, okay? But the idea is that your curiosity, each one of us has our own wounds curve. Your curiosity increases as you give more stimulus. If you give too little stimulus, you're bored and you just don't care about that. If you give too much stimulus, you're anxious and you also pull away. You don't want that content. The idea is to hit this zone of moderate stimulus where the user is attracted. And this curve models in the general term this idea. And the idea is that each one of us has one of these. And what people are starting to do is start to infer this curve for each user and build it into the recommendation service. But again, this is very generic, right? What's the stimulus? What does stimulate one's curiosity? Most of the work in computer science, at least that I'm aware, into that try to fit that, work in this axis here. How to estimate something that drives curiosity. The most immediate thing that most of people work with is novelty. Something novel triggers your curiosity. And there are different metrics of that. But what this literature in psychology tells you is that it's not only novelty that triggers curiosity. For instance, something that is very complex, not too complex, but complex enough, triggers your curiosity. You want to go and look further. Something that triggers different signals in your brain, something that is pleasing, but also confusing. We call it conflict. This triggers your curiosity. And what people start doing, and that's where we enter in this idea, is to propose metrics that try to operationalize these very vague concepts of conflict, uncertainty. And these metrics we built for two contexts. One in the sense of where users consume information, so curiosity as a driver for you to consume content. In this case, is music. And another in the sense of information production, curiosity as a driver for you to share content. And we did it for the WhatsApp, and in the WhatsApp groups. And in that case, particularly interesting because you have like a group of people who you are sharing content with. So there is another dimension that we will start looking at, which is social curiosity. There is this huge body of work on social influence that looks at the person, how it influences others. Here I'm looking at others influencing me and driving me to do something, which is slightly different. So what we did is to propose a bunch of metrics that capture all these notions, and we characterize profiles of curiosity stimulation, how a given piece of content stimulates my curiosity, and how these stimulus evolve over time, because it's not static. And then we build profiles of users. And once we have these profiles of users, how users are stimulated in terms of curiosity, we can build a model of curiosity stimulation, much in the sense of the Wundt's curve in the psychology domain. And one novel thing that we found here is that most of the papers that worked with this when we started, they worked on the stimulus and then they plot the curve, and then they used that single, it's a beta distribution, that single bell shape, they use that as input to the recommendation. But what we found is that it's not always a single beta distribution. People are more complex than that. 40% of the users in our data set, they have this mixed behavior. There's not only a single curiosity zone, but there are two or even three. And this is because of how dynamic the environment is. We're talking here about music. You have different genres of music. People like different types of music in different moments. They are stimulated. What we're doing now is using this as input to the recommendation. And these are results that are still on the oven. They're still coming up. But we are seeing that we can, by identifying these profiles, things that, imagine that I have a trace of what people listen, what they usually listen over time, and I use that to give this profile. And then I can use that as input to a recommendation function. And then I can provide more personalized recommendation. And we are finding some evidence, some initial evidence that this can actually improve the experience. So this is an example of one front that we're working with, that it's focused on the individual aspects of user behavior. What I want to talk now is more on the second half, and that's where I want to spend most of the time, which is collective. So even when I started, I had this inspiration that I had to look at the users, as I mentioned. This was like in the early years of web. So web 1.0 before social media. Okay? And even then, what we saw is that all the standard assumptions that we had for performance modeling, they broke. No Poisson assumption, no independence, nothing in the web. It's very complex, several levels of scale, different hierarchical behavior. It's very complex. When you go to the social media, the third generation of the web, things become even more complex. Because now we have collections of users, groups of users, acting, some of them completely independent, some of them in coordination. And from the collection, the net result of all these interactions, phenomenal core, for instance, campaigns to disseminate a particular piece of content. Campaigns are not necessarily bad. For example, Me Too campaign. This is an effective, good campaign. But there are campaigns for bad things, like campaigns to disseminate fake news. And that's actually what motivates this line of research, of my research. So by collective behavior, I mean kinds of activities engaged in by sizable but loosely organized groups of people. So I may not have an explicit link between two people, and they might still be participating in this collective. And I want to infer that. I want to find evidence of that. Okay? To study different phenomena. And here we have applied that in different domains. And here I'm going to talk specifically in the information dissemination domain. So if you think of collective behavior interactions, the first thing that should come to your mind is that, well, okay, let's build a network. Let's build a network where edges represent interactions. For instance, if I want to understand the dissemination of content, I want to model users sharing messages or comments on a platform. And I connect users who share the same content, who exchange messages, who like the same content. You can think of interactions as anything that is important for whatever you are studying. Okay? For instance, fake news, hate speech, ads, whatever. But in case what we have, let me go this way, is you have a collection of interactions over time, over a certain period of time, and you build a network as you join these edges. Each edge is an interaction. What's the challenge here? People have done that for many years. I have done that since, I don't know, early 2000s. What's the challenge here? The challenge is that if you collect this group of interactions, try to build a model to study a phenomenon, what you usually see is that some interactions are consistent and repeat consistently over time. Maybe because these users, they are attracted by the same type of content, they are interested in the same things, etc. But some interactions, they are random or sporadic. And I will explain that even in a specific context, then becomes more clear. But when you put them all together into a single network, you have something that we call a noisy network. And the noise here are edges that they are either weakly related or completely unrelated to the phenomenon you're studying. So now let me give you a concrete example. Let's say that I want to study campaigns to disseminate fake news. So what do I want? I want groups of users who are coordinating, they are orchestrating to disseminate that content. So I don't want to capture, for instance, edges between Jussara and Nicola if they shared content independently. I never knew him, I never met him, and because this particular content is very popular, the both of us shared it. And so there will be an edge between us. But this is not coordination. Coordination is me telling Nicola, please help me out, share this and promote this. And I talk to many people, and we do that massively. That's what I want to capture. If I just add the interaction, because this is not in the data, you don't see me telling Nicola to help me out disseminating. It's just another edge. So some of the edges are not related to campaign at all. How do I find those that most probably are related? These are what I call the salient edges, or the relevant edges for the phenomenon, in this case, the campaign. And there is this body of work that tries to extract these salient edges, and they call it the network backbone. So they inherit this name from network, where you think of the network backbone in the sense of like topology. You need a minimum for the network to be operative. Here is more than that. You want the edges that are really representative of whatever you are studying. So it's very vague, right? And the problem of, if you do not look into the network backbone, is that the amount of edges unrelated to the phenomenon is so usually huge that it's not only that they do not help you understand, they hurt, they make it much harder for you to understand anything, because they are the vast majority of that. So the challenge here is, which are the eggs that I should look at? Well, this. In this case, I need to look into this too, for instance. Now, what's a relevant salient edge? So immediately you can think, Jussara, just look at the heaviest edge. They reflect the most people who interacted the largest number of times. These are the campaigns. Sure, I agree with you that in this case, the heaviest edges probably are, if there is any campaign there, most probably these edges make part of it. However, it's not always, they are not all the edges that belong to the campaign because, and then comes something that is very particular to the web scenario, you have different levels of activity of the users. You have users who who write and share content and participate very heavily and others less heavily. Sometimes you may have less active communities, but that they are the many communities that are less active, but collectively they contribute to the process. You have the long tail. That's something very common on the web. You think only of the most popular, you talk about the head of the tail, the distribution, but the long tail makes up a great part of it. So if you just take the heaviest edge, you get a lot of that important edge, but you may miss some important ones as well. Less obvious, but it's still important. Another method, it could be like take the edge that belongs to the most shortest path. This is actually a method. This doesn't relate to campaign, but it could be important, for instance, if you're studying anything related to reachability and you want to be short path. And indeed, there are many different methods in the literature. Every year there is a new, there's a short period of time with many papers published on that topic. Some are global, make a decision globally. Some are local, take a decision based on the node or the edge. Some explore structural properties, the weight, shortest path. Other exploit a probabilistic approach, some sort of hypothesis test. And but the point is, once we start studying that, we got a bit lost because there are so many different methods and no strategy to either select a method or evaluate a method for a given problem. So what we did is we took a step back and tried to understand what makes the backbone extraction method good for a particular phenomenon. And how can I evaluate one? Because usually we're in many scenarios, we're thinking of groups of users. We're talking about communities. A community is very tightly connected. So I'm talking about a community detection test, which is unsupervised most of the time. So evaluation is challenged. We don't have a ground truth to compare. Are we good? Are we not? We don't. So what we did is we took a list of methods, the most commonly used, and we proposed a methodology to select and evaluate. We characterized them, we identified their assumptions because this was not listed anywhere. All the papers were like, use this method, here's the result, use this other method, use this other result. So we took this effort to take a step back and look at the methods at a more fundamental way. And we then applied it to different case studies. And that's what I'm going to talk about now. And one of the case studies, actually 3 different scenarios, but essentially the same thing, is the example that I just gave you, which is to identify information dissemination. What I want is to identify groups of users who most probably are coordinating, are orchestrating to disseminate a particular thing. That's the goal. And we did that for different contexts. The first one is fake news during the Brazilian election, and I'm talking about the 2018 Brazilian election, not last year. But here I need to take a step back and explain how we started doing this research. So back in 2018, WhatsApp was huge in Brazil, as it still is. But there was a lot of reports on it being abused for fake news spread, massive campaigns. And there was a huge concern, especially on the election that took place in that year. So, but there was not much literature on how WhatsApp worked, on how users used WhatsApp, because what we knew. WhatsApp, we have this personal message exchange, but that's private, we don't care about that. But there is these groups of users restricted to 256 at most. Many groups, they are publicized on the web, so they are effectively of public access, but they are restricted to 256. And yet we could get some pieces of content that were replicated on the platform thousands and thousands of times. No explicit link, no social network in the platform. So how could the piece of content get this spread in such a platform? We didn't know. We started looking into images, and then we move on to look at textual content and audio messages. We did a bunch of content analysis, but try to identify properties. But I'm not going to talk about this. I'm going to talk about our effort to try to infer the dissemination of content on the WhatsApp. So since there is no network, no explicit network like we have in Twitter, which is not Twitter any longer, but anyway, Facebook, Instagram, there's no explicit link on WhatsApp. So we start thinking of potential, what we call implicit networks. They don't exist formally, but they are potential channels through which information could be propagated. For example, the group network. We connect groups together that have users in common. Same using two groups could take content shared in one group to the other, and then you can have a potential channel for the information to propagate. Another network is the user network, where you connect users together that who share this content in the same group. The same user in two different groups is a potential channel to take content from one group to the other. And what we saw, when we go here, is that once we applied complex network metrics, we measure properties of these networks from a complex network perspective, we found different properties like communities, hubs, grids, the diameter, everything, very similar to what had been reported before to social networks, to explicit social networks. And that had been linked to the potential of the platform for content virality. So even though we are talking about implicit networks that don't explicitly exist, at least in a potential level, there is effectively possible channels for large spread, as we observed in practice, right? So then we were caught with this idea, and we want to delve deeper into this potential network. In particular, what we did next was to look at the correlation between the communities that we saw in these networks and the groups, the formally defined WhatsApp groups. But here we looked into a different, yet different network. We call it the media-centric network because here we already focus on the idea of campaigns. So the network that we built here is we connect two users if they share the same content, and it's a weighted graph. So the number of times that the two of us share the same content is the weight of the edge connecting both of us. And it's a very noisy network for someone who wants to extract communities here. There is a measure of community quality called modularity. I will be showing it every now and then, but it's a standard way of assessing the quality of communities, and it's very low here. So what we did, we had to apply a backbone extraction method, right? To uncover the silent edges. And I want to be aggressive in the sense, or conservative, if you can think of in another way. I want to keep only the edges that I have high confidence that it's evidence of coordination. Everything is potential, right? Because I cannot claim for sure that those two people coordinated, but the chances are high. That's what I need. And I illustrate here the importance of backbone selecting the backbone extraction method. So this one here is the original network. The one I showed before was just a sample. This is the original network. And each one here is the backbone extracted by a different method. So you see that some methods here are horrible, just as horrible as the original one. If you think of trying to identify groups of users, they have the same color here. Here, I just illustrate what we found when you run the community extraction. Here it's completely noise. Here we can find some communities, but still very weakly defined. The best are indeed these two, even better than this one. And we had this idea of not looking only into how well structured their communities are, but we want a backbone that helps me understand the phenomenon. So one way of doing that is to try to correlate the edges that are kept in the backbone with the phenomenon. And we do that with a regression analysis. This is in the first paper that I mentioned. And if you look into that, what sees is that this method here, this direct filter, is the best approach. So I apply that. Let me tell you how this method works. The idea is the following. The decision on whether an edge is salient or not, meaning the decision on whether this edge represents coordination or not, is done locally at each node. So I look at this node and I look at the edge incidence rate. The disparity filter has this assumption that the weights of the edges incident to a node should be uniformly distributed. What does this mean? This means that if I'm representing pairs of users who share the same content, from the perspective of this user, he should share the same content uniformly distributed with his neighbors. More with one, less with other, but shouldn't deviate a lot from the uniform distribution. That's the assumption of the method. You could question whether this is the best assumption for campaign, but it worked well. I actually have some ideas of even improve that, but this worked quite well. So what do? We look at the node and we look at the weights of the edges incidentally. If I have an edge that deviates a lot from this assumption, it's much larger. It could, given like a hypothesis test that this is uniformly distributed, it fails. So that's an edge that probably is not independent behavior, probably it's coordination. So that's the whole idea of disparity filter. Anything that deviates in a probabilistic manner from uniform distribution should be kept. And once we do that, what we have is very clearly defined communities. This is just a sample of them. And then we looked at the users in these communities. And one thing that we observed is that even though WhatsApp has these boundaries, formal boundaries of groups, 256, group 1, 256, group 2, 256, group 3, when you look at these communities that have evidence of campaigns, of being orchestrated, they have members in most of them. So they're basically formed by users, groups of users, one in each group, and they all share in the same content. So we have like this massive league of people in different groups promoting the same content in different groups. So that's how you get scale of spread. So far, so that this is the first evidence that we got, but I haven't talked about fake news yet, right? What we wanted to do is, okay, so we have these communities who are promoting content effectively. What about fake news? How many of them are indeed promoting fake news? What's the percentage of fake news that comes from them? So we had to identify fake news in our data. And what we did is we relied on those people who know how to do that, not us, the fact checkers. So what we do is we generate a list of main fact-checking agencies in the country, in Brazil. Those are agencies that are made up of journalists who check the content and add a label, fake, true. And what we did is for images, we submit images to Google search, and we looked into the result and see if any of the results page was one of the fact-checking agencies. If it was, we went to the page and we searched for the label. So those that have been checked as fake, we labeled as fake. For text and for audio, and we use the transcriptions, what we did is we download the fake facts and we compared with the messages. Those that were similar enough, we labeled as fake. So by this time, we had some of the messages labeled as fake or misinformation, and the rest. The rest we call unchecked, because we don't know. If we didn't find them on the fact check list, we don't know. These are just some examples. This one is an image that was fake, and this is an audio transcription. This is very gross because this is a former president with a very strong image related to the left wing in Brazil. And this is a fabricated image of her close to Fidel Castro, trying to link her to communism. But this is fake because by the time he was this old, she was a kid. So you just need a little bit of history and math to know that this is fake. And this is another case of an audio transcription about voting patterns in Brazil. So the first question is, where in the network are the users who more often share misinformation, the top users, those that share the most the largest numbers of fake news? And what we saw is that if you look at the media-centric network again, what we saw is that the top misinformation users, they are indeed benefiting from this implicit network because they are very well positioned. They are in the center, according to different metrics of centrality. This is this red curve here. And even if you compare the most active users engaged in this information with the most active in general, those engaged in this information, they are really centered in central positions of the network. And why is this important? Because this gives dissemination efficiency. You reach many people very fast. But what about the backbone? What about coordination? That's what I cared about, right? So if you think of the backbone as carrying those nodes or users who were involved in coordination, and whoever is removed, which I call the periphery of the network, those that are involved in isolated actions, mostly independently, what we see is that approximately in the backbone, reflecting coordinated actions, 16% of the nodes only, and 4% of that. We're very aggressive in removing and leaving and keeping only those that have high confidence with respect to coordination. But the vast majority of the top users involved in misinformation were here. So they were indeed involved in coordination. We usually have this drawing here where you have the bad guys in red in the center introducing content, usually as part of a coordination campaign, and a bunch of people naively reproducing this content or forwarding when they just forwarded without checking. And that's exactly what we see, because even though most top users involved in misinformation are here, they represent at most 41% of whoever shared misinformation. There is a massive amount of people who are participating in the process just by forwarding, not coordinating, but just by forwarding what they don't check. And if you look at the messages, around up to 53% of the messages with misinformation come from here, come from the bad guys. But what's interesting is that they introduce new content, new fake news into the platform most of the time. So perhaps if you look at them, to search for them, you may be able to stop the process early on in a significant portion of the time. It's not as simple because the backbone is highly dynamic. From a week to the other, the backbone changes, the community changes, and the members participating in the community changes. So it's very, very difficult to track. That's why I think, and I always finish every time I talk about fake news, that I don't believe in any purely technological solution. Because what really contributes to the process is that massive amount of naive people who are propagating it. But anyway, in this line of trying to identify coordination, we also applied a similar strategy to two related, two different contexts, but related. One was on data from now Twitter. So we departed from WhatsApp and we're now focusing on Twitter. These are tweets in English collected from October to December 2020. And the collection was done using keywords related to fraud during the US election. So this was not gathered by us. This data set was gathered by a project called Voter Fraud. So their idea was actually to study the whole process that culminated with the invasion in the Capitol after the election. And they shared this data with us. And while they were much focused on the text of the tweets, we here were interested in the communities of users that we could extract if we looked into the potential coordination here. And one thing that these guys did that was quite interesting is that, well, days after the invasion of the Capitol, so we had this log of tweets posted by people who were actively participating on Twitter. And then there was the invasion. Few days after the invasion, Twitter did a massive moderation effort to try to suspend over 70,000 accounts related to sharing content, extremist content, claims of fraud during the election. So this is a major thing notes in several journals. And what the voter fraud people did is that a few days after the moderation effort by Twitter, they went through the data and they labeled the accounts on whether the account was still active, suspended, had been suspended, or had been deleted. Deleted is a small fraction. I'm particularly interested in whether the user was still active or had been suspended. And if they had been suspended, most probably they were suspended by Twitter because they shared extremist content. So again, what we did is we built a network connecting users who retweeted the same content. Very noisy network. We want evidence of coordination. We want to keep only the backbone. And this case was particularly challenging because disparate filter didn't work fine, didn't work well. This is the modularity, which is a measure of quality of the community. It's actually worse than the original. And the reason for that is something that we didn't anticipate, but had to do with the way crawling Twitter works, because the guys use the API, and the API offers you a sample of the data. And dealing with sample, when you have like a reference model, like disparate filter have, the assumption of uniform distribution, it really breaks, it doesn't work. So we had to change the method to add a more conservative approach, call it neighborhood overlap, where we keep not only edges that reflect persistent and repetitive connection between the users, but those between users with a large number of neighbors with similar behavior. So we're being very aggressive to focus only on those very tight communities. Note that I throw away a lot of nodes and I throw away a lot of edges. So everything that I talk here is already with it's a lower bound on any conclusion that you can take, because I'm looking into a very small sample because of this aggressive assumption. But here at least I can see communities very clear. And what we saw when we look at the members of these communities. So here each dot is a community on different weeks of analysis. And I have on the x-axis the community size. So I have groups with thousands of users promoting the same content related to claims of fraud in the election. And first, I see here is the percentage of members of the community with accounts that have been suspended or deleted. So I have up to like around 60% of suspended users. So you could think at first, oh, so the moderation is good. A large fraction of users of these large communities, they were indeed suspended. However, then you can look on the other way. There are many large communities here where the fraction of users whose account was not suspended was very small. So these are users who have very similar patterns in terms of sharing claims of fraud with those that had been deleted, and they remain active in the system. So I'm not advocating for moderation. I'm just giving an example of the limits of moderation. Because every time I talk about fake news, there's someone who says, but the platform should do something. But it's hard. If you think of an event that could trigger a major moderation effort, it was the invasion of the Capitol. And this was a major. And yet, there were many, many, many users with similar patterns that remain active in the system. And these are just some of the examples of tweets that came out among the largest communities, all of them talking about massive election fraud, massive voter fraud, etc. Another scenario that we try to apply this idea of coordination, this is very specific to Brazil. This was a collaboration with the public ministry, was to detect coordination to disseminate electoral propaganda last year in Brazil. So I don't know how it is here in Italy, but electoral propaganda in Brazil is regulated. There is this old law, long time on course, that electoral propaganda can take place start only into a specific date. So if the election is like in October, it's allowed to start only August 1st. And the reason for that is for fair share. There's a bunch of reasons for that. Okay, but it's been around for many years, and it's been under control for mass media like TV, radio. And if you don't, people who break that, is actually there is like a sanction that you had to pay. And the ministry, the public ministry, was rightfully scared about, well, concerned better, of how things will take place in social media, because that's no one's land. And our experience with social media in the 2018 election was major. It played a major role in the election. So the public ministry was really concerned about social media last year's election. And we actually had two fronts, one focusing on fake news and the other focusing on electoral propaganda. And the concern was actually the convergence of them, because most of the propaganda contained fake news somehow. Right? But here I'm talking about electoral propaganda. And so the goal here was try to identify groups of users who were orchestrating to disseminate electoral propaganda outside or before the allowed period. That's what I call early electoral propaganda. And we did that for Twitter. Again, we built a network of whose users who retweeted the same content and content considered electoral propaganda. This by itself was challenged because electoral propaganda is a very fluid definition. It doesn't need to be posted by a candidate. It doesn't need to have a name to explicitly mention a person. It could be a third person talking about someone, as long as you uniquely identify the person, that's considered electoral propaganda. So this was quite challenging, but we managed to propose a strategy to detect, and then we focused on trying to identify campaigns. And again, we applied the same strategy. And what we found, and this we didn't expect, so election last year was October. Propaganda should start on August 1st. This is on data collect up to July 1st, from January to July 1st. So it was completely breaking the legislation. We expected that for some candidates, particular candidates, but what we observed, and this is just again a sample, some large communities promoting content, and we had that for all the candidates. I mean, we had for the right wing, we had the center, we had the left, everyone. So it's really a no one's land that's been exploited massively. And what we did is we built a tool for the public ministry. And then what happened? Elon Musk happened. And our life became really hard, because now Twitter we cannot collect anymore. It's not even Twitter anymore. So we are in the process of seeing how this is going to evolve. I mean, the methodology, the general technique works for different sources, but the problem is that the tool has a crawler that is built for Twitter under the Twitter API, everything under what was considered legal at the time. Now we don't know what's going to happen with that. Well, I'm really finishing up. I just want to talk one last thing. This was a work that we did in collaboration with Polytechnic de Torino back then, and was in the first fronts where we exploit this idea of backbone. But here we're not interested in campaigns, we're rather interested in modeling discussions online. And discussion is not only you comment on something and then I go comment on something else. I need evidence that the two of us really interacted through those comments. And I need structure of this, topological evidence. Right? So I built a network where I connect users who comment on the same post in Instagram. And the noise here, why is this a noisy network? The noise comes from the fact that some posts are very popular. Some posts are shared by influencers who are very popular. And now this may drive the attention of two commenters who acting completely independently of the message. They didn't interact. They didn't discuss, but yet they left. I wanna reveal the edges that most probably reflect true discussions. So I need to isolate effects due to popularity or due to activity level. Two users who comment a lot, the chance of them both comment on the same post increase. And here, what's novel is that we have this tripartite structure different from the other methods. They usually had like a bipartite method structure. Here we have a tripartite structure. We have a user, an influencer, who attracts attention, who posts a comment, and he may post different comments on different topics. And the comment posted by this guy on a particular topic calls the attention of some users who comment on that. So I have influencer, posts, and commenters. And I have to take into account all of them to decide whether an edge is relevant or not, whether an edge reflects two commenters actually discussing about it, or simply posting something there, completely different. And we propose a method to do that. It's called Tribe, that takes into account these probabilities. And when we applied it to the data, the Instagram data, we managed to identify different communities, very well-structured communities of discussion. And even we managed to differentiate communities that were discussing different topics, even though they were discussing different topics posted by the same influencer. And we do that not looking into the content, we do that looking into the structure of the network. But once you look at the content, then you see that indeed it's different. So there's one community talking about posts related to social movements, posted by someone supporting Bolsonaro, one of the candidates, and another community of users commenting, discussing topics related to racism, also posted by the same influencer. Okay. We did that for different contexts, not only political, for Brazil, for Italy, political and in general, and to validate the use of our method. And we also compare it against different strategies to validate this idea of the tripartite structure. And what we found is considering both the topological, the network perspective, but also the contextual perspective, Tribe deliver the best trade-off of the metrics. So, to finish up, I tried to give you a glimpse of some of the efforts that we are doing in Brazil to model user behavior online. I have this interface, even though I'm not an expert with, even now I touch social science because it's really something that I like. But I'm always thinking of the system as I have always my mind in the system, either to see how these findings can support decision-making or improve the online environment in the case of fake news. There's a lot of challenge in this type of work related to heterogeneity, complexity, and noise, as I mentioned, or irrelevant signals, how to get rid of them, how to focus on what really matters. And in the case of collective behavior, we have been working on network backbone extraction for a few years. Evaluation is quite challenging because often you have an unsupervised task, and it's not only topological, Sometimes the topology is very good. You have very tightly connected communities. But when you look at what they're doing, it doesn't make much sense. And one thing that I haven't talked much, but it's something that we are interested in exploring, is the idea of the temporal evolution of this. We saw that it's very fast. Things change very rapidly. So the idea of modeling these dynamics over time is something that I find particularly interesting and challenging. So I want to thank you all for being here, actually now, 1 hour later, and listening to me. And I'm open to questions.
Any questions, guys? Stefano?
More of your question, but I was wondering if one part of how to protect communities and how to then how to spread. I was wondering if you have never thought about using these strategies. For instance, within communities there must be nodes, I guess, that at least start spreading first, but at least the more massive nodes, relevant players, so not like sort of players, for instance, for game, there must be, I guess, some nodes that can be identified with like methods like the shape of them, where you can understand how much one player has an impact on the game.
Very nice. No, the short question is no. We tried to do something like this, but in a slightly different context, but that's what they to take me. But also, we tried to model attention in WhatsApp, collective attention. And what we saw is this, exactly this. Some users would come along and would caught the attention of everyone, and then there's participation. We saw that a little bit when we tried to model social impact, but we haven't linked that to the efficiency of the separation yet, which I think is, yeah, that's an interesting.
Thank you.
Other questions? Yeah.
Thank you for your talk. So I have actually 2 questions. First one is about your WhatsApp data. You're very bit on how you get that, if they are public or
Yeah, so this is back in 2018. What we did, this is actually a collaboration with another professor, and he has a tool called WhatsApp Monitor, but it was not built for general audience. It was built specific for journalists. And the idea there is that we harvest links to WhatsApp, links that are shared publicly, like Twitter, Facebook, etc. Then you join the link, then you announce yourself there, and then once you announce yourself, you remain there. Then you have basically data, and that's what you have. We and there what we have is the, well, not even the number, the telephone number, because once you download this, okay. So this was done in an effort. This professor, that is my colleague, he has a project called Elections Without Fake. So this was an effort to try to, it's not moderation, but show what was happening in WhatsApp at the time. Because there was lots of news talking about abuse of WhatsApp. And I myself had a meeting with WhatsApp guys, and it was very hard to try to start the idea. And so the thing was to try to expose what kind of content was being shared and the amount of fake news we shared. So there is a tool that actually I shared this research called Hiram Garinello, where he automatized this stuff. You basically enter, once you have a link, you enter with your cell phone and then you can buy it. And that's what you
the second question was about the backward part of your presentation. So I was wondering sometimes being able to use information without being discovered or actually without someone discovering organized group might be useful. For example, I was thinking about feminist protests in Iran or something like that. So, some cases being able to protect people who use information might be
Yes.
certain thing.
I agree.
Your approach to be used in order to protect people who want to use the child information.
I totally agree with you, and I said that because I had to make this disclaimer. Campaigns are not by definition bad. Right? There are good things, and these we actually we tried to gather data in the context of Ukraine because there was some discussions about them using to help out. That was not very successful. We tried Telegram, that was not very successful. In that sense, you cannot protect them, but we may be able to identify these groups that are, but I don't know what you do with it is really up to you. You could do for good with that. So I don't know if you can actually help him, but we can identify these groups if possible.
Fabio?
Thank you for the talk. I have a question concern with the diffusion of fake news. In particular, I was wondering, is it feasible to identify with a high confidence whether a diffusion of a post it is a naive diffusion or and distinguish it from against a malicious diffusion of a post?
Yeah. If by malicious you mean intention.
Yeah, with intention to coordinate groups to diffuse fake news instead of someone else who has no knowledge about the fake news and share it.
As long as you have a model of what a naive person should behave, you can always test that. So the disparity filter has this assumption of uniform. If you are sharing the same thing as me, you're going to share approximately this uniformly distribute the number of times with me, with him, etc. If you deviate from that, you're sharing a lot in common with me, probably there's. You could question whether this is the best reference model. Maybe you want like a normal distribution. You can co-share more with him because he's your friend, close friend, and less with me, and even less with me. And then suddenly you see a match with a very, very heavy weight that deviates from normal. Then it's a reason. So I think the challenge here is to distinguish what's a strong evidence of each. If you have the argument, and then probably it's not myself who's going to find that. I have to like social science. They probably know that better. And then you could identify, but there are challenges of running this network vacuum extraction in a non-line setup because they usually have that. You have to decide whether you want a global method that takes the whole method, not viable for social media, or whether you can take like an incremental method that looks at part of the network with a decision impact. Then it becomes more viable in an online setup. So there are ways of trying to do, but I think fundamentally is whether you are able to distinguish the coordination, what assumptions of coordination. And here we propose one, but you can think about this.
Thank you.
Francesco?
Okay, well, that's
Okay.
thanks for your presentation, and my question relates with the one of Fabio. Do you plan to analyze also the impact of automated bots in your communities or for their potential?
We tried to do that for the ads.
Hmm.
Okay. We were sure, very, very sure that the community had high percentage of bots. They didn't. We tried several basic analyses like presence of bots, toxicity, it's heavy. But bots for sure, we were very confident. This is going to be huge, and it was not. We had bots in the community just as much as we had bots in the outside in the community.
Okay, so you
For the propaganda, for the fake news, I don't think it maybe.
okay. Thanks.
The thing is that we have bots for so many things nowadays.
Yeah.
Not all of them bad. That that's what we observed, and we didn't see any special signal.
I don't have we have discussed that before, but I mean, we have a we see that the backbone matter as a way of moving the relevant or not for eggs for the job. And we thought about the connection with our talked yesterday about streaming. Can you elaborate a little bit on that?
You want me to tell the guys what we
Yes.
Yeah. What we're thinking about doing now is that we were always searching for points of connection. Right? So Marcos told you guys about that idea of selecting is for training them. So you could think of the backbone as selecting edges for learning in the context of a graph neuron. So one thing that we're trying to explore now, and this is like a couple of weeks, right? That we thought. I mean, at the same time, we thought a student of mine who did this was thought, and someone else mentioned, so it was like a convergence of everyone talking about this, is to try to bring this idea of backbone as a filtering, as the first stage filtering for graph neuron. I mean, it's not, it's a wide idea, very wild, and still has to be elaborated. The assumptions when it can work, whether, and even like what is relevant for learning, right? I mean, it's a new, the good thing is that there's a potential of developing new backbone extraction methods specific for learning. I don't even know if it's a general for learning, but possibly learning for specific scenarios. Yeah, for particular tasks. So that's something that I'm trying to explore.
Okay, I had also a question and along the lines of Francesco about the bots. I was wondering if the new things with large language models and these generative tools can change the behavior of bots, maybe make them more malicious or more suitable for this purpose, because I was saying that you were labeling or trying to detect fake content based on similarity, but with generative AI, you can reformulate the same stuff in a longer, shorter, so it becomes more and more difficult.
Yeah, definitely. Even before ChatGPT was already, we saw very sophisticated patterns and things evolving very. And if you look at text and look at the audio, the transcription of the audio is completely the narrative completely different. And we did that, and it didn't show, but it did lots of I think we are always one step ahead, behind, because the generation of computers with ChatGPT and large language models is only going to become more complex. And I'm actually more worried about like deep fakes, videos and audios too, but videos, images, because people are getting to a level of sophistication and accessible to everyone. That it's really,
Yes,
really
it's very low price.
low price, very so yeah, it's concerning. That's why I mean I used to give a talk specific on fake news, and the end of my talk I was very negative. Yeah, I think it's hard. I don't think there is single bullet. I don't think it's a technological solution is by itself effective, because of that massive amount of you guys, and it's hard. I think education, media literacy is key. I mean, it's a convergence of different things. Like moderation by itself doesn't work. The legislation by itself doesn't work, because we saw with the propaganda. You need efforts from all of them.
Thank you. Any other questions, comments, yours, please? Okay, so let's thank Jussara.